My name is Daeyoung Kim. I'm a professor of School of Computing, KAIST, South Korea. I'm also running Auto ID Labs KAIST, which is a research partner of GS1, which is Global Standard 1, International Standard Development Organization. I'm also participating in several of the Korean Smart City projects. I'm very glad to introduce our Smart City project, in which we are actually exploiting GS1 international standards. Let me share my screen with you. Actually, let me begin with this picture, which was taken a year ago in Bali, Indonesia. Actually, I'm holding a red salmon. Actually, this the event is a hackathon. Which is for the traceability hackathon, organized by Global Dialogue on Shipment Traceability, which is actually established by IF, the International Food Technologists, and the World Wildlife Fund, WWF. Actually, in this event, we were a technical support, and then we provide our open source platform, which is OLIO, Open Language for Internet of Things, which implements actually GS1 standards. Actually, this GST was formed by request of World Economic Forum in 2013. Actually, at that time, traceability was identified as a key to sustainable, the management of ocean. So in 2015, this organization was established. And this year, actually, this year, this organization released the GDST 1.0 standard to achieve international shipment traceable system. This standard actually is using GS1. From this year, the many shipfood industry company is started to build this traceable system. Why I introduce one is that actually in this seafood industries, this industry is actually made by many countries, many companies, and then they use actually they generate their own data for the traceability system. All actually fragmented. So using a GS1, they could actually integrate data in standardized way. So like that, in the smart city, actually in Korea, in a single city, we believe that there are more than several hundreds of heterogeneous platforms. They do have their different identification system, different data format, and also different APIs. So all are fragmented in silo. So to solve this silo problem, we need pivotal points of interoperability, like suggested by NIST, United States NIST, in their cyber physical systems framework. So among different architecture and framework, we have to find a common pivotal point of interoperability. GS1 standard could be acting as that role. So in legacy city platforms, all actually fragmented, but we want to believe, we want to actually build a smart city services. In between then, GS1 could provide PPI, pivotal points of interoperability, such as identify, capture, and share and use. Like a human, actually human share their knowledge and experience by recording and uploading and share, as Yuval Harari said. Also, an Internet of Things, many things like red salmon and also Testbeds 2020 in France. In this Internet of Things era, we need to actually identify things and capture the event data are coming from the scene, and we have to share with some common API, and we have to use it for building some smarter services. GS1 is the nonprofit standard development organization, which provides some standards for actually business and industry by uniquely identifying all the resources and accurately capturing our data and automatically sharing those vital information about the thing. The thing is actually product, location, and assets, and then use it. This international standard organization consists of 115 member organizations, and also there are more than 2 million companies and organizations are members. Actually, KAIST is a member of Auto ID Labs, which is a research partner of the GS1. This Auto ID Labs is actually consists of MIT, Cambridge, ETH, Fudan University, Keio University, and KAIST. Actually, in 20 years ago, actually, Auto ID Labs coined the word of Internet of Things. I'm sorry. To join this GS1 community, every organization or company should obtain a GS1 company prefix. For example, here in Heineken beer can, you can see the barcode. This barcode is actually GS1 identification code of the product. So A71 is a country, 2000, it's a Heineken, I mean, it is Netherlands, A71 country code. 2000 is a Heineken, and 02551 identify this 500 milliliter, the beer can. So as well as this product code, GS1 provides asset code, location code, service relationship number. I mean, a total, up to 12 different category of GS1 codes are actually proposed. So in Korea, actually, we start to use this GS1 in the standard to build smart cities. For example, last year and this year, four cities in Korea, like Seoul Songpa district, Siheung, and Daejeon, and Busan are now a member of GS1. And then using a GS1 identification system, we can identify city services. And also we can use a GS1 returnable asset identification number to identify this rental bike, and also bus and location like a bus stop, and also patients and nurses. This is a GSRN service relationship number, and also some document IDs. So as well as identification system, GS1 provides a common business vocabularies which could populate this kind of data model. That data model we call EPCIS document. So in the document, we put all standardized information. For example, in this example, AstraZeneca is actually a UK company who produce a COVID-19 vaccine. Actually, this is a global supply chain from SK Bioscience, this Korean company, to DHL, AstraZeneca, and up to the American hospital of Paris. Okay, all located in different companies, and the data generated from different countries and different companies. So using this common data model, we could share the data. As well as data sharing, GS1 provides a service sharing mechanism. Those are digital link. Like a web link, GS1 provides a way to give a link to everything. Okay, the thing is product, services, and locations and whatever. And also, using object and name service. This is distributed service repository. If you give a GS1 ID, it can be location, thing, whatever. It will reply with a list of services with which you can access services which is previously registered to each the thing. So those GS1 standards are popularly used in especially in industries. For example, Internet of Trains in Europe, including Switzerland, France, and Germany, and Austria, Sweden, and Spain, and also Australia and India. They started to use the GS1 standard to share data which is generated in railway industries. For example, using a GS1 identification system, they identify every vehicle and every railway station and even railways, and then share the data generated from these railway industries. So as well as the train industries, from aerospace, apparel, automotive, and also smart factories and custom. Okay, there are more than 50 number of industries. They are exploiting a GS1 standard to share data originally fragmented and stored in each company. So as a research partner of GS1, we are actually participating in standardization activities. And also we implement latest GS1 standards to check interoperability and disseminate these standards to the world. So we implement open source Olio, which is now being popularly used in the world. So using these GS1 standards and also Olio project, we are carrying out several smart city projects in Korea. For example, we work together with the Ministry of the Interior and Safety. Actually, they are governing Korean address systems, as well as building addresses. Usually, every country give address to each building, right? And also in Korea, we give address to the things. We give address to the spaces. What we are doing together is we map every address to the GS1 global location number. For example, this is kind of digital twin, right? You can see many buildings over there. So we give an address to this building, and also we give a GS1 key, the code. Interestingly, Building Smart International, who standardized the BIM, Building Information Model, they already adopted the whole GS1 identification system. GTIN, GLN, SSCC, and GIAI. So this one is the example of how we map postal address. Actually, this is the building currently I'm in. So this is a Korean address. We map to like a barcode, right? Country and the city code and the type of the street addresses. And this is a serial code actually. So city code, street code, building number, and some detailed address. And those address now mapped to GS1 global location number and represented in GS1 120 format, URM format, and digital link format. Actually, this URM format and digital link format is used in current Korean Smart City project. So using this standard, what we can implement is, for example, this is a smart city service provisioning platform. So as well as the city, we can, the citizen and civilian company engage in provisioning the smart city services, right? So together with the GS1 data link technology, and GS1 ONS technology, actually we combine them together, and then the implement as the service provisioning platform. Using this platform, actually last year we deployed this system in Seoul. Actually, this is a tallest building of the Korea. In front, this is a Lotte Tower. In front of a Lotte Tower, there is a very popular and beautiful lake. And this lake has 2.5 kilometers of trail. So in this trail, we installed 120 number of address signs, okay? And this QR code is standard GS1 data link code, QR. So this QR contains GS1 code, which corresponds to the address. And then you scan it using your camera application or our GS1 Genie application. We developed this one. And you scan it, and then all those services. Through Google Map, you can locate your current positions, okay? But we do not develop this Google Map service, right? We just provide some service like, the registration and, discovery, systems, okay? So as well as this city, this year, we actually deployed 920 number of the bus stop signs. Actually, in Korea, we give address to this bus stop also, right? Okay, so here, this QR is a GS1 global location number. If a citizen scan it, then the pre-registered the services be accessed by the citizen. This one shows the example. Okay, so
QR 코드를 찍으시면,
yeah, you scan it, and then this one is forwarded to the Kakao Map bus arrival estimation services, right? Just link it. So you can get the bus arrival information. Also, you can click Google Map. Okay, then you can find your current location. And this is about data sharing. This is a Siheung city. This is Korean popular smart power city, and this is a digital twin. In Korea, every city has its own bus information system. So identification is all different. Data format is all different. API is all different. So it definitely they are fragmented. Okay. So what we did is to map all fragmented data to standard data using GS1 systems. Okay. So that's what we did. And actually, we are participating in more other data. We actually participate in EU Horizon 2020 project. We work together with the fireware. I mean, we are working together with the fireware to connect the fireware ID platform and GSO platform, something like that. Put everything together, we are put together in a KAIST campus to make a smart campus project. So we are building digital twin. This is our campus. Currently, I'm actually here, okay? And then in building this digital twin, we try our best to exploit the current international standard, which could be very good fit to build smart cities. For example, GS1 for data and service sharing. And also we use BIM, which is standardized by Building Smart International. And also all, this campus was built on a city channel and also indoor channel. Okay, so that's OGC. And on top of this digital twin, we are actually running autonomous driving delivery robot here in campus, and also some energy service, something like that. Okay, finally, I'd like to conclude that anyway, there are many ways to solve data fragmentation problem. Okay, I suggest it's also better to consider this kind of international standards when we build smart cities. Thank you very much for listening to my talk. Thank you.